real pleasure to be presenting Trends in AI, the June edition from Zeta Alpha. My name is Jakub Savrel. With me, co-host Two Times the Charm, Dinos.
Yes. Hi everyone. Welcome. Very nice to be here.
So what are you most excited about in the program?
For today?
Yeah.
We have quite a few nice features today, and I think I'm looking forward to the information retrieval stuff. So stay tuned.
Dinos is our resident dense retrieval specialist. Oh, very good to have you here on the show. So let's dive right in. So we have a lot of topics. It's very hard to make sense of all the new stuff in AI. It feels a little bit like this, bam, bam, bam. Everything that is kind of new for this month from about 2 weeks ago already feels old. So let's dive right in. And let's start with some news. And we'll start with some news from a company which is not especially well known for its large AI exposure and investments. But beginning of this week, we saw this fancy pair of ski goggles for $3,500, right?
Yeah, I mean,
are you getting one?
I don't think I'm getting the first gen. That's a common concern that people have. Why am I jumping in? And I don't think they marketed it for everyone just yet.
Vintage iPhone 1 goes for above the original price now.
Oh, so you're thinking investing in one?
Yeah. So while it might not seem like actual AI news, because it's just a pair of virtual reality glasses and augmented reality, you might be surprised. It's actually a full computing system with a pretty powerful CPU and GPU in it, the M2, and a new chip from Apple called the R1. We don't really know what it is, but I just guess that R stands for reality. And it's responsible for this super fast computation. So not only does it have some powerful chips, it has 12 cameras, a LiDAR, I think, 5 other kind of sensors and 6 microphones. And it's actually kind of tracking everything around you, like who's coming towards you, where your hands are, what gestures your hands are making. It's got eye tracking. So it's actually one of the more sort of, sentient beings out there right now. So other news from the same developer conference of Apple was that Apple, who was kind of missing in the large language model space, is like totally into large language models now, because with the next release of iOS 17 out next month in beta, it's going to include a transformer-based language model for the autocorrection.
Well, we'll see. Will it have biases? Have they worked on that? It's going to be target of.
But it's going to be very private, right?
Yeah, I think they
your
push,
own transformer that only works for you. So in TechCrunch, they made the headline: thanks to AI transformers, iOS will learn your swearing pattern, so you no longer have to autocorrect it when it says ducking, for example. That's not the end of the world. That the AI extinction risk,
existential risk
committee had in mind when they wrote this letter. So this was a pretty big discussion online in the last few weeks. So there was this earlier letter about a 6-month moratorium that didn't really get people so heated up, but now there was this petition, just 22 words, mitigating the risk of extinction from AI should be a global priority alongside other societal scale risks, such as pandemics and nuclear war.
And we see some pretty big names now on it. I'm sure some of them had also signed the previous one, but I guess this is a bit easier to get behind, even if you're from a huge AI corp like OpenAI.
So Jeffrey Hinton was already outed as a kind of AI doomer. Now Joshua Bengio joined the crowd and actually wrote this pretty long blog, How Rogue AIs May Arise. Did you read it?
No, I haven't read it in depth, but I've seen a lot of people starting to get behind like either Bengio or LeCun. So now it's kind of getting, who's the authority on this? Who should I trust? Since they all were equals before.
So I think the main question that's in the room is kind of Okay, so where does this existential risk come from? Can you explain how this is actually going to happen? So Benjo actually gives it a try and says, well, you might have these AIs that are very capable, and now they want something that we don't want. They have goals. And interestingly, the example that he comes up with is like, well, like a large company, it's also more intelligent than any of its parts, and it can want something like, I don't know, produce fossil fuels that nobody wants, and then right. But yeah, all in all, so basically all of these luminaries have outed themselves as kind of extinction warriors, at least. But personally, I think there's much more pressing worries. Like, for example, this is largest nuclear installation in Europe, right in the front lines of the Ukraine war. And this lake, where it's taking its cooling water, is actually about 5 meters lower level right now. But let's not get into that. It's an AI show after all. But there's another thing to say about these AI doomers petitioning about existential risk. Just this week, Sam Altman was doing the rounds, not only in US Congress, but also visiting Europe and Israel. And this picture kind of reveals a little bit what his goals are, I think, lobbying the European Union.
I mean, when you have the power, you probably want to make use of it. And I think that's what he's behind now.
And I don't know if it is exactly coincided with the petition. So there's a piece about regulating AI on the OpenAI website, where they kind of make the case that AI should be regulated. But then in the sort of fine print, they say, we think it's important to allow companies and open source projects to develop models below a significant capability threshold,
What does that mean? Yeah.
or some threshold undefined, without the kind of regulation, including burdensome mechanisms like licenses and audits. All right.
So I want to see who's going to be the one that comes up with a threshold and who enforces that threshold.
We think that it has more to do with this document here, which is the European AI Act, which was actually kind of draft approved in European Parliament Commission on 16th of May, just before all of that other stuff.
And it's pretty aggressive on AI companies, right?
It's it's been in the works for about a year, and this latest version has a couple of notable amendments. So in particular, it bans AI systems for a couple of applications, like absolutely no biometric surveillance, no emotion recognition, predictive policing. There was a recent letter to the European Commission by open source people like Lion and a couple, also a pretty large list of AI researchers, arguing that open source should be exempt. And it's actually made it into the draft. So that was pretty successful.
That's a nice move.
Jürgen Schmidhuber was behind that one. For real. And of course, the AI law, European AI Act, was also kind of amended to take into account the availability of these large foundation models. And the proposal that it makes that they should comply with additional transparency requirements. For example, disclosing the content was generated by AI, preventing generating illegal content, but also they need to publish these kind of document model cards that summarize which data was used during the training, including copyrighted material. And I think this is really the sore point.
Mm-hmm. And fewer and fewer companies start doing this as they're releasing their models. When it's commercially intended, then you kind of see, oh yes, we trained on a lot of data. We trust it's good data, but we're not telling you what kind of data it is.
The GPT-4 or technical reports.
Palm 2 also.
Palm 2 the same. The thing is, if they publish that it's taken this and that newspaper archive, immediately they get sued for copyright infringement, in the US at least. So we kind of think that this whole AI doomerism is being manipulated for this purpose of softening down the European AI Act. Not everybody agrees with AI doomerism. So a couple of notable figures did not sign the petition. Jan LeCun is, I think, the most prominent one. And here he expresses his viewpoint by agreeing with Francois Chollet, who says, well, there is no near-term chance of anything like extinction. So let's just proceed with normal, good engineering practice and responsible management of these systems. King-Yun Cho also kind of questioned the motives of these hero scientists that are going to save us from extinction. In fact, some people argue exactly the opposite. Mark Andreessen from Andreessen Horowitz, venture capital guy, wrote this nice essay, Why AI Will Save the World, where he kind of, one by one dismantles, I think, pretty successfully these arguments of AI doomers. And he actually argues for the opposite, that we have a moral obligation to proceed with the advancement in AI, not only because of the sort of productivity and business impact, but also because it might actually be necessary, one, to solve a lot of these much larger problems, and second, he argues that it's a kind of a geopolitical thing. Well, either China gets the advantage in AI or US does. So this copyright thing is not seen equally all over the place. So Europe is pushing very much in one direction. Japan goes all the way in the other direction. It says, well, copyright doesn't apply to AI training. It's basically like people reading books. The learning process itself is not subject to copyright law. If the model then produces something like, let's say, a Coca-Cola logo, reproducing that falls under copyright law, but the learning process, no.
Do we have any big labs in Japan working on AI, or do you think this is going to be the spark that starts?
Well, I think there's definitely like different viewpoints also in Europe, right? Like Europe has a very different position because none of the big tech companies are based here. Yeah. So Japan basically says copyright doesn't apply to training AI models. Open source is, of course, maybe exempt a little bit in the European position. Open source is really catching up with OpenAI and closed models. The latest and greatest is, I think, Falcon.
This has definitely made a lot of buzz in the news for many reasons. And I think mostly now the taste that people have is positive after switching to the commercially free compatible license. Yeah, so initially when they launched it, they had this weird license. It's like Apache 2, but if you're a commercial user, you need to pay royalties if you're above a certain size. And then, this was very complicated, but they quickly changed that within a few days. So it's now completely Apache 2, available for both research and commercial use. And the most important thing, so there have been a lot of large language models being released into the public domain under various licenses. But the interesting thing, this one is really good. On the, I think this is a Hugging Face. They've hosted like an evaluation of, I think 4 datasets where they're creating prompts for each model, or certain prompts that they test all the models with. And then they're trying to compare, like in equal terms, for challenging tasks, how do they do language generation and question answering. Yeah, and basically Falcon tops both Llama and Vicuna and all these other sort of Alpaca. And I feel like there's still an asterisk involved in this because the papers reported in the Llama paper are different than these ones, and a lot of the figures are different. Yeah, and a lot of people are saying what are the prompts that you use for this data set, or what are the prompts that Meta used, and since no one is releasing the prompts, it's kind of difficult to have a fair evaluation of the models. So I think there's still work that needs to be done there to kind of make it consistent, because you don't know. These models are shown that they're very sensitive to the prompts and the input. So it makes sense that these small changes may lead to an inaccurate listing in the leaderboard. So, and by the way,
there is now a paper, not about the model, but about the data set that it was trained on. And it has a pretty good representation of the major languages. So it's essentially a pretty good multilingual model. I think it's good on Russian, German, Spanish, Japanese, French, Chinese, Italian, Portuguese, with some support for Dutch, Polish, Czech, and a whole lot of other languages. So still to be tested. It's out for 1 week now.
I think a bit more.
Have you tried it yet?
No. They've made an accessible version that is 7 billion, and then for the 40 billion, you're kind of getting in the edge of what even professional GPUs can fit in a single unit.
Oh, we'll get to that in some of the papers later on.
Mm-hmm.
But this is the paper, and it also kind of sheds an interesting light on who's behind releasing this model, because TTI is a research institute from Abu Dhabi, and of course, some of the Middle Eastern universities have been on the rise in AI research rankings, but we haven't really heard a lot from this research group.
Yeah, I didn't even know it existed, to be honest.
So Professor Al-Mazrouei is the leader of that AI group, and if you look at, however, at the author list of this paper, which describes the construction of this data set, and they claim, by the way, that the quality of this Falcon model is for a large part due to the quality of the data set, the extensive cleaning and duplicate.
They employ all these kind of tricks that modern models use, like Llama, Palm, and such, but they attribute their performance to cleaning the data really meticulously.
I think they like a much higher percentage, almost half of the data is cleaned out. And interestingly, on the author list, a lot of these people are actually from France, not from Abu Dhabi, and they're working, a lot of them, for the company Lydon, which is one of the European large language model startups or champions. We did contact them and ask how they were involved, but they haven't answered yet, so we'll keep you posted on that. Probably in Abu Dhabi they are able to afford quite a lot of GPUs. I think it was trained on AWS with around 400 GPUs. One of the other major announcements in recent weeks was this NVIDIA supercomputer that you can just buy, topped up with 256 H100s and CPU and memory for a total of 144 terabytes of memory. So I think you can train 1 or 2 large language models, maybe GPT-5. Maybe some Altman is waiting for delivery of one of these to start training GPT-5. We've looked at, in our data, in Zeta Alpha, we, together with State of AI, we regularly track the use of hardware in AI research papers, and we've just updated this State of AI compute index. You can see that the absolute numbers kind of level off because the number of publications this year has not grown as much as last year, probably because these are absolute counts. But we basically see that NVIDIA is still completely dominating there. If you can check out the report on the compute index side. Interestingly, H100s are not mentioned at all in research papers yet, not even from Abu Dhabi. So it's still a bit of future. It's been announced over a year ago, the H100. So probably it will now start rising. Let's move to other news.
That's not so news.
That's not actually news. That's fake. So a lot of stories this last few weeks around AI were centered on actually disinformation, or there was this explosion at the Pentagon, which supposedly sent the stock market down a few percent until people realized it was fake. There was the fabricated court cases that were cited in a briefing by a lawyer and got caught. What could happen to any student. It was made the headlines all over the world. And there was an interesting fake video which was hacked by Ukraine secret services, probably, into television stations in Russia, where Putin was saying, calling for a complete mobilization and telling people to evacuate. There's also this story about a rogue AI. I don't know if Joshua Benjo was behind the story or. So let's move to some more business news. Some of that is already pretty old because it's 4 weeks old now. So Palm 2 was actually released. Finally, we've been crying out for it for many months now.
And I think the waitlist is actually moving pretty fast to get access to it, right?
We have access to it.
Yeah.
So it's available in the Google Cloud as a service. It's a little bit more complicated to use than OpenAI API. And we tried it out, and it kind of doesn't listen very well to instructions in the prompt. So I don't know what that means. Other kind of old news is that Inflection AI introduced this Pi personal assistant. Has anybody tried it out here? It's 4 weeks old, and I think, come on, if you haven't got on after 4 weeks, it means it's kind of yeah, it's failed essentially, right? There is another one which is called Character AI, where they launched an AI powered sort of personal companion app, and it had about 2 million downloads in the first week. So is anybody using that? It's all very US centric, this stuff. In other news, this Builder.ai raised humongous amounts of money. Anthropic raised another 450 million to buy one of these NVIDIA supercomputers, maybe. Cohere yesterday announced another funding round. They just got funded like 270 million. On top of another stuff. It's just all astronomical. What I think is two pretty interesting ones are that Anthropic introduced the long context window with Claude. Do you know how it works?
Not really, but I know that many open source models are now getting these long context windows as well. So
it's a pretty big deal, right? Moving from like 8,000 tokens to 100,000 tokens means completely new application cases are being opened up.
But I feel like they still need to be evaluated and seeing how reliable they work.
Absolutely, yeah. So the last one that we want to mention here is Lightmatter. They also got a big round of funding for developing this kind of optical hardware for AI compute. And I think that's a really important direction because that's kind of the most promising direction of developing really energy efficient systems that are like 1,000 times or 10,000 times more energy efficient than NVIDIA GPUs. In case you are not using Zeta Alpha yet, try it out. That's the platform that we built, and that's also the platform that we use to stay informed about AI. So it's basically a platform where you can discover and organize your research updates in the topics personalized to your own collections and tags, and take notes. And then you get very nice recommendations based on that. Did you get any good recommendations?
I think some of them are here.
Most of the papers that we got as recommendations we're going to be discussing in the next section. And of course, we incorporate generative large language models also to help you make sense of those discoveries. This is basically kind of the main application pattern that we're using, not only to answer questions and give summaries about research papers, but also working with companies to basically allow them to use GPT models on their own internal data from in the company, where the retrieval augmented model is the main way to do that, and also to improve factuality, avoid hallucinations. We also use large language models and social media signals to find the relevant and impactful papers of the month. So this is a map of all the papers for this month. The size of the nodes is the number of mentions on social media, and this helps us to, with a little bit of human curation, to pick out the 10 papers that we're going to discuss now. A little bit more than 10. All right, so let's dive into the first one.
Yeah, we made a lot of mentions on how more and more open source models are being deployed and released, in contrast to the supercomputers that the closed source companies are employing to train more robust models. We've seen papers like QLoRa, which are basically proposing new ways to train more efficiently, to fine-tune basically pre-trained language models on data like either supervision for any task, or also to fine-tune or to create chatbots and stuff that can be used in any kind of service. So this paper is really interesting.
So what does QLoRa stand for?
It's probably quantized LoRa, which is two techniques that already existed, but they have combined them pretty efficiently to kind of beat the state of the art, both in quantization and also the performance that these models can reach.
So it's a type of adapter model, right?
It is an adapter
low-rank
model.
adapter.
Yeah. So they boast a few innovations that they needed to make this happen. Namely, they use a new kind of data type, which is the 4-bit normal float. It's basically an information theory optimal data structure to store the weights of the model.
So they basically like slice up the buckets of the float range and then stuff it into.
And they observe that since weights normally follow a normal distribution, we can use some tricks for quantization that will help us throw away most of the bits, going from 16 all the way to 4. And also they said, why quantize only once? We can actually quantize the quantization constants. So let's bring the bits per weight even
because
lower.
If you quantize and you slice the buckets of the float range, you need to remember where you sliced.
Yeah,
right?
exactly. So they said we did this once. I think that was in the original Int8 paper by a few of the same authors, and now they said, oh, actually, we can push this even further and get. They say really sneakily that if it's in one GPU, but it's actually in one 80 gigabyte GPU, because they fit their 65 billion model in 44 gigabytes, which is a bit over the 40 gigabyte that most would be comfortable with. But still, nonetheless, they can pretty much do huge model training in a single compute unit. And if we go a bit down to the 30 billion one, that fits comfortably in what most people can have access to in these cloud settings. And then, of course, they have these third trick, these paged optimizers, which is just to avoid certain out-of-memory issues that can arise if you use long
so they
long
can
inputs.
basically very easily swap between GPU and CPU memory. It's a really nice paper, by the way. They introduce also a new open source large language model, Guanaco, which performs pretty well.
Yep,
right?
they say that they can reach 99 or 90-something% of the ChatGPT performance in just one day of training. Of course, now what does that mean? Evaluation language models is kind of all over the place now, but they also propose, I don't think they're the first to propose, but they evaluated with this ILO ranking system.
Yeah, I haven't seen it before. I don't know if it's actually a novelty in this paper, but they basically use the chess player rating system, tournament rating system, ELO, to derive a relative score. And they do that by having GPT-4 as the judge who's the winner. So you can basically just generate outputs on a benchmark and then ask GPT-4 who won the tournament, and that gives you an ELO rating. It's pretty neat. They also do it validate against human.
Yeah, they also have some human evaluation, and they show that whatever GPT-4 says, the ranking stays pretty much consistent, plus minus 1, 2 places in the leaderboard.
Yeah, so QLoRa is on GitHub.
It's open source. I think, I don't know when this screenshot was taken, but I think it just checked before the presentation. It's almost at 6,000 stars, so it's
definitely one of the trending GitHub projects. And this Guanaco model has a space, Hugging Face space, so you can actually use it as ChatGPT right there. I tried it; it's pretty high quality. And there's a very recent paper. We haven't had time to really read it yet in detail.
From some of the same authors again, and this is kind of complementary. They're just showing how can we take a trained model and then just squeeze as much as we can, all the quantization that we can achieve, and basically get it to be in a compressed version that can run on an even smaller GPU, let's say on an end device like a phone or I don't know, maybe some vision goggles.
Vision goggles would fit the largest model without quantization, but yeah. So I think they show here that you can get a 65 billion parameter model to run in 32 gigabytes of memory. That's pretty impressive. So the second paper that we highlighted as probably pretty impactful is this Sophia paper. So Adam here from Amsterdam has probably dominated neural network optimization as much as NVIDIA dominates GPU, but it's over. Maybe, I don't know. So Sophia was released by this group from Stanford, I think, and is basically a kind of drop-in replacement for Adam, and they claim that for the same size of model to reach the same level of accuracy, you can do it twice as fast using this new optimizer. So that's a pretty big deal because that saves you very large amount of compute cost. And the way they do that is by actually looking at the second order characteristics of the error landscape by looking at the Hessian and having an efficient way to calculate that and store that. They can basically avoid kind of going in these zigzag pattern, but take much larger step, because by looking at the Hessian, you can kind of see much more clearly where the steepest descent is.
I read a nice joke on Twitter. They said, if you're dating someone in AI and you have a kid, you have to name it either Adam or Sophia. So these are nice name advices.
We'll see that show up in the statistics in a couple of years. But first it must prove itself, and actually we'll be probably monitoring.
Yeah, I'm looking forward to the first big model that uses it. Hopefully soon enough.
All right, so our third paper, you read this one in
this is
more
also
detail.
Interesting, and some pretty big names working on it. And they pretty much found that there is a mapping between the reward model, the reward that function, and the optimal policy that a model can use to generate text. So we all know RLHF or RLHF, and they basically require you to first train a model on reward data. So
yeah, this is for instruction tuning, right?
For human annotators who would say this model or this output is better than the other.
So basically, the RLHF kind of requires you to go through this whole series of steps. First, you train on human preferences, then you build a reward model, and then you use that reward model to actually
train your
final instruction tune model.
Yeah,
and they argue that it's kind of you don't need to do that. You can do it more or less in one step, right? Yeah,
basically through a lot of smart reinforcement learning equations in all the paper.
It's a very mathematical
paper, but they show that implicitly, if you adjust the loss correctly, you can actually make it a classification problem. So you kind of remove the whole step of training the reward model. The loss function can itself prioritize good responses over bad responses as a classification problem. Which is quite interesting. They do try it out on a few tasks, namely sentiment classification, text summarization, and dialogue. But it remains to be seen that if actually the quality of all these translate to what humans prefer.
And if
when
you
using these models,
actually want to train one of these large models with these human preferences, whether this actually works for the whole sort of multitask instruction tuning, right? But it looks pretty promising. This is another paper in the same category.
Yeah, and this is also making quite some strong claims. They're basically saying that, you know what, we don't need to worry too much about alignment, since if we're really careful with the samples we select, namely here they only select 1,000 prompts, basically from online.
So I think InstructGPT was trained on about 100,000 prompt initial.
And
prompts.
it's probably a lot more costly to actually go through and remove data that's bad, rather than carefully selecting very few that are, are high quality. So what they did is they went on community exchange websites and selected very few prompts or question answer pairs. Then the authors also created their own extra kind of out of distribution from that the data prompts for the model to use. And then they trained using, again, no RLHF, purely on language modeling. So they took I think Llama 65 billion, and they showed that just by having these very well curated data sets, we can reach the performance of, I think it's compared against GPT-4, right? So
yeah, they don't quite win from GPT. It's kind of like this ELO ranking.
But they're not claiming to be better than GPT-4, but they're saying in almost half the cases, it's at least as good, which for the compute, which again, they're claiming that this is a simple supervised fine tuning. So you can do it very fast for any pre-trained model. So you kind of align it to your output style. So I'm a AI assistant. So it really learns that from very few epochs of training. And yes, it seems that models like Bard and ChatGPT is much easier to reach.
I guess it's from Meta, so the boss says alignment is easy, so they have.
But his name is not on there.
His name is not on the paper. All right, so the fourth paper in our selection for this month is a paper from a team at NVIDIA. About half a year ago, they released this framework called Mind Dojo, which is kind of an agents framework to learn, through reinforcement learning, but also using video and text and examples of gameplay in this Minecraft world. And now they kind of extend on that with this paper called Voyager, which is kind of subtitled GPT-4 Learns How to Play Minecraft. And basically the setup is very interesting because they use GPT-4 to do two things: to kind of design a curriculum, to be a mentor for the agent, and kind of identify steps which are useful to learn next. And the second thing that GPT-4 does in this paper is to actually kind of build tools. So little subroutines that can be reused in the future. It kind of packages them in some kind of programming language and stores them in a retrieval engine. And then later, when the agent is roaming around, it can match its state with the contents of that retrieval engine and retrieve these tools, basically. And what they show, you see that here in this graph, is that this a Voyager agent learns much faster and gets much much further in the game very quickly than the same system React without this, but also React and AutoGPT, which are kind of older.
Older, but it's like 1 month.
Like 1 month. Yeah, exactly. So yeah, pretty nice paper. NVIDIA had some other nice paper as well about recording a video with your phone and making a 3D model out of it, but we didn't pick that one. Kind of related to that is the fifth paper in our selection, Gorilla, which is a study of how tool use by large language models in general can be facilitated. Basically, what they do is fine-tune a llama-based model to help with the construction of API calls. So it's a little bit like ChatGPT plugins. They basically, the model has to generate a valid function call to some external library. What they do here is basically, again, store all of, generate good descriptions of these library calls, and then retrieve them from an external kind of embeddings enabled database. And they also construct a data set that can be used in this line of research of tool used by large language models called API Bench. It's not very diverse, though. It doesn't cover the full range of tools that you could think of. It just has function calls from Hugging Face, TorchHub, and TensorHub. And the last paper in this sort of series of tool use by large language models, or tool creation by large language models in this case, is this paper, Large Language Models as Tool Makers, where basically the loop is that if a certain number of examples are presented, the model is asked to generate a Python function which can generate these examples, and then stores that again in the memory. So it's a kind of a pattern. If you use find similar in Zeta Alpha, you probably find at least a dozen other papers which are about tool use by large language models. This is a bit in a different category. It's about the reasoning by large language models.
And I think it's one of my favorites from today's highlights. Basically,
so can you explain briefly what it does?
Yeah, we all know and love the chain of thought prompt family, that the model itself tries to explain what it's doing in an attempt to reach to a better conclusion. And this method is basically a new decoding paradigm where we again use chain of thought. So the prompt itself asks the model to go step by step, but then instead of just producing one step, we sample the model a lot of times to get many step number one from the chain of thought. And then in a self-critiquing manner, the model again says, actually, this one is probably not good. Let's not explore it further. And so this is a tree search algorithm that you generate more steps in either depth first or breadth first, and you reach to a better conclusion, is what this paper shows.
Yeah, so basically you kind of expand the chain of thought in a couple of steps, and you do
some
a
pruning,
little bit of
some
backtracking there. And they show that it has on a couple of different tasks like Sudoku and crosswords and Game of 24. No, not Sudoku, actually. But it has like significantly better performance because it requires planning, right? And yeah, step-by-step planning is a good idea. One downside of this paper is that the prompts that are used for different tasks are actually like fully hard-coded. So if you want to write a good story, you have a completely different chain of thought prompt than if you want to play a Game of 24. So yeah, this was a pretty big software release, most of all. So in speech recognition, the standard has been sort of set by Whisper recently from OpenAI. So this is a release by a team from Meta, which released a model that can recognize speech and generate speech in more than 1,100 languages. At a word error rate of half of that of Whisper. So that's pretty significant for anybody who wants to use speech recognition or generation in their applications. It's basically not a very big algorithmic improvement. They just use Wave to Vec 2.0. But they basically trained it on a lot of, pre-trained it on a lot of monolingual data, and then they kind of fine-tune it on people reading the Bible, which is available in almost all the world's languages. So it's a collaboration between Meta and Christianity. And not only can they do that for 1,100 languages, they have a language recognition from speech for more than 4,000, and it's completely open source. So let's move away from language and speech a little bit more into vision. And
I think these kind of demos are more eye-catchy than just showing a an error loss going down.
That's true.
Yeah, basically.
Or quantization, just memory being reused.
Yeah, definitely an interesting work. So GANs again are getting some popularity after the diffusion hype return to normal levels. So what they did here is basically when you have an image, you can adjust it in any way you like by transforming points from one place to another. And the intuition was that the generator and discriminator space is enough, is structured well enough that you can do this motion transformations. So what the model does, and actually they've built supposedly a whole UI for it, which you can see in the image, is you select a point and where you want it to end up, and the model itself in an iterative process will modify the latent space, sending that point basically towards the target, then track where that point actually ended, because it's not going to be perfect in one go, and repeat this process again and again until you achieve the result that you want. And it can actually do a couple of things, because also when you ask for, let's say, the lip to go higher, the model then will understand that you want a smile maybe to appear. And also they have a region where you can, like shown here in the lion, that you only want the photo to change in that region and not the rest. And their technique works pretty well. And since
so Adobe also released this sort of Photoshop generative plugin.
Yeah, I'm not sure what's the underlying model. I'm not sure. I have not used it.
You can kind of expand, right? You can. So this like Mona Lisa, and then they in-paint the rest of the landscape.
But we've seen this before with diffusion models. Is kind of like their image-to-image translation.
Yeah. So this is not included yet, you think?
I have not seen it, no.
So this is more in the realm of video.
Yeah, and in self-supervision, generally, people have seen that for video, we have a lot of redundant signals, and there's a way to actually make use of that to train a model that does this feature correspondence in a self-supervised way. So what they do is they have two encoders, which is simply a bit encoder, and they mask aggressively one of the two frames. So these are two.
So these are subsequent frames.
So two subsequent frames from a video.
So they're not that different, right?
Yeah. So what they do is they aggressively mask the second, and they train a decoder that does cross attention between the two to learn where a feature moved from one frame to the other. And just by this, they learn a pretty good correspondence feature that beats the state of the art in or matches the weakly supervised models in tasks.
Yeah, we have some benchmarking table here.
Yes, as you can see, they compare with Dino and VideoMay. Yeah, like they propose features that are normal in like image segmentation and pose estimation, stuff like that.
Is it better than Dino V2 also?
I'm not sure. I didn't check the numbers for V2.
It's always good to choose a strong benchmark, a strong baseline. So this is kind of related.
Yeah, because again, we have
come out also a couple.
Yeah,
days
this is.
ago, right?
I think this is this week's emergence, and they're basically saying that for diffusion models, we can use the latent representations to do this automatic feature matching. So we all know from computer vision, one of the oldest algorithms was SIFT, where you could detect basically features in an image. And here they say that if we simply take any kind of image and do the diffusion process and take the representation or the state of the diffusion model in some layer down the line, then we can do this feature correspondence without any kind of supervised signal for training. So simply by adding noise to the image and then taking the representation at a layer at the given time step, you can see where that feature actually moved for another image. So
it basically proves that diffusion models do representation learning of some kind.
Yeah, exactly. And one application that's kind of fun that they propose is this kind of edit propagation, where if the model is so good at detecting where the same feature kind of is both cross-domain, like shown first that you could have an actual photo of a cat and then a painting of a cat. And then if you want, let's say, edit the cat's face, you can also do that correspondingly in another.
So diffusion models don't want to stay behind, they want to drag your diffusion, right?
Definitely a lot of competition
it would enable that, right? All right, so I think we're almost at the end of the hour, but we haven't touched on our favorite topic yet, which is, of course, search, retrieval. So we kind of squeezed in a lot of IR-related papers that we thought were noteworthy. I think this one is pretty interesting because it looks at the problem of like classical learning to rank allows you to fuse a lot of different signals. And now when you move to neural models, where do you put all these classical re-ranking signals like page length and recency and number of citations, etc. This paper uses a called fusion in T5, basically just does the most obvious thing that you could do, namely just throw all these features as text into a T5 model between the query and the passage, right? Is this cross encoder, and you just throw in a bunch of re-ranking features there, and you train it to figure it out, and with pretty good results. Actually, a very similar paper was published at ECIR, right? Yep. By people from Leiden University. They use BERT, here they use T5. I think the results with BERT were not so convincing. Here with T5, they get some pretty good results, 43.9 on the MS Markov passage retrieval development set. I think so. It's pretty good. Easy does it. This is an interesting paper because it kind of solves for a completely different problem, that actually a lot of natural language queries are kind of Boolean queries in disguise, right? You want birds found in the Venezuelan Andes, but not in Colombia. Well, embed that and try to figure out how to, how to find a document that satisfies this condition. With a Boolean search, it's really easy. What this Quest paper does is not solve the problem, but just make a data set that that can be used as a benchmark for solving that problem. And they also discuss the situation kind of in that picture there, where the different pieces of evidence for that Boolean combination are in different passages of the document that are embedded separately. And coincidentally, not using this data set, a very nice paper came out from the group of Andrew McCallum at the University of Massachusetts, answering compositional queries with set-theoretic embeddings, where they kind of have a solution for this data set, which works by not using point like vectors as points in a embedding space, but using this concept of box embeddings, where the concepts are actually kind of volumes in the high-dimensional space, and then you can do interactions as intersections of these volumes instead of just distance calculations. So check that out. I think they have some results on their own data, not on Quest yet. And this is in dense retrieval, so the area that you're working on.
It's a pretty interesting approach. They're basically trying to combine every kind of model that we use in dense retrieval. So they do see the value both in dense retrieval, in cross encoders, in bi-encoders, and also late interaction.
Like Colbert, right? Yep. Like Colbert is the prototypical late interaction.
But they are saying that each of them has their weaknesses, and they try to combine all of them in a single model that the way they do it is they kind of simulate a cross encoder by generating synthetic query representations for each passage during training and offline.
So the advantage, of course, of a bi-encoder is that calculation of the distance at query time is really cheap using approximate nearest neighbor, but you kind of lose the real interaction between the query and the document. Mm-hmm. So how do they do that?
Yeah, they propose that for a given passage, when we try to encode it offline, we can actually create this synthetic query representation that will allow us to use a cross-encoder-like model on top. So given there are approaches in the past that were like doc2 query or doc2 query that took a document and expanded it into a query-like string. Here, instead, they work on the latent space. So they create an embedding for a hypothetical query that could correspond to that document, and then use cross-encoder architecture on top to generate a new embedding for the document that is kind of query aware, that could match with a real query at inference time.
Yeah, so if I get it correctly, like when while you're encoding this passage, you also generate a question that could be formulated from that document.
Exactly, yeah.
Which is at training time aligned with the real question that belongs to that passage.
Yeah, so they do add some modules. So you don't only have the query encoder and the document encoder, they add some more neural networks in between, but they kind of adjust by downgrading the query encoders themselves to kind of keep in the same parameter count. But they're adding this query reconstructor model and the passage interactor model on top, and they're producing new embeddings that are enhanced.
And inference time is a pure bi-encoder, right?
Yeah, because at inference time you do have all these document embeddings saved, and you're just encoding the query as it is.
Right. Pretty cool, and they have some very good results. So they're actually beating Colbert and the state of the art in this pre-will, which I think is Retromay, right?
So they're only evaluating in domain here, and at least for the Retromay case, after distillation and all the kind of usual tricks that people use nowadays, it's kind of close. But I would be really interested to see if this does help solve the problem also in out of domain
on the beer data set. Yeah. There's one sort of fine print thing. These models which beat Retromay were actually initialized with Retromay. So, okay, I think that's a bit of a weak point, because if you would do nothing, you wouldn't beat it, but at least stay close to it. But they do beat it on TrackDL by a pretty good number of points. So that brings us to the end. We're at the end of the hour. Usually we try to spend a little bit of time on what's trending on GitHub. We don't have a lot of time for that now, but basically a lot of the papers that we mentioned, like Gorilla and QLoRa and Tree of Thought and others, are trending on GitHub. So what we see is that kind of the world of research papers and the world of open source code is moving closer rather than further away from each other. I think Falcon is not on GitHub, but it's on Hugging Face.
Yes. And it's also interesting what implications this will have on the next generation of models that are trained from scratch.
Yeah.
Like if they start integrating all these new tricks, where can we get?
And the other sort of category of things that are trending on GitHub are these things like that a lot of script kiddies like to try out, like Super AGI and Local GPT and all these things, which are not, or face swap. So that's more what's popular with the young crowd. With that, we end our show, and we just wanted to end on a lighter note. So we've been talking about extinction and the end of the world, but AI can also solve very everyday problems. So just wanted to share this little video that was posted on Reddit. If you have some very small problem that you need to solve, right? These are really annoying problems in everyday life. So they yeah, come on. This doesn't look very good.
I think now you can finally take the perfect vacation photo without worries.
There's this guy who fixes Photoshop issues on Twitter the wrong way by doing exactly what you say. So watch out for that. So that's it for this month's Trends in AI. And we want to wish you a great weekend and enjoy discovery. And the next edition is going to be July 7th. That's our last before the summer break. Again, here live from Lab 42. But in the meantime, we also have a kind of traveling edition of Neural Search Talks from Berlin Buzzwords, which is in 1 week in Berlin. Very practical, engineering-oriented search and storage conference, and we'll be doing interviews with people there about neural search. And last but not least, mark your dates. We have a date for Transformers at Work, our annual workshop that's going to be here in Science Park September 15th. So that's it. Thanks.